All right, the most important variation for this class is the standard deviation. Now, there are three ways you can symbolize the standard deviation, and you might see all of them at some point for this course. Typically, we use the letter S, or your calculator uses SX, but the letter S is generally used for standard deviation. APA notation uses SD, or computer software, and what I often use myself for an abbreviation is STDEV, standard deviation. Now, before I get into the formula, let's try to think about what the standard deviation measures. What you see below here is a sample that has each of these three samples has a mean of 95, but a different standard deviation. Suppose we want to rank these distributions from largest to smallest. So I want to look at see which of these has the most spread. And looking at them, it looks like B is the most spread out. So I'd put that as 1. And then the least spread out is A. So I guess C would be 2 and A would be 3. Now if I calculate the standard deviation, that's basically what it turns out to be. And essentially what it measures is you take the mean is 95, so say like this first part B here. Standard deviation of 4 basically means that I'm going start at 95, I go up 4 and then down 4. That kind of gives me an idea of the average value of these values, average distance from the mean. Same thing with set C and set A. Now, as for the formula is somewhat more complicated than the range and the quartile range, and there's a lot more work necessary if you want to do it by hand. Really, no one realistically does standard deviation by hand. And you might be asked once in your homework, but for the most part, it'll either be given to you, or you can just find it with your calculator or computer. But let's talk about how it comes about anyway, just to give you an idea of where the formula comes from. To calculate the standard deviation, there are 5 steps. The first step is to take the mean and subtract all your data values by that mean. That gives you called the deviations. After we subtract the mean, then we square everything. Then we add up those squared deviations. Take that sum and divide by 1 less than the sample size to get the variance, and then do the square root. So, a lot of steps there. If you want a compact formula, this is the compact formula. And we're really not going to be using it, but feel free to look at it. Essentially what we do is that this x here represents all the data values. And what we do is we subtract the mean, square, and then this symbol here is add them up, divide by 1 less than the sample size, and then square root. Now let's take an example. And I'll go ahead and start off doing this with a computer. So let's say use formulas to compute the mean and standard deviation of the following set of data. Say my data set was 35, 42, 60, 29, 39. So 5 numbers. If you're using using RStudio or some program, you'd first start off by defining your data set. So that command like x equal to C 35, 42, 60, 29, 39. And then RStudio has this command called SD for standard deviation. So SD of x, and you get 11.68332, or 11.7. Now let's see if we can get that same result by hand. Well, first thing I'll do is I'll just go ahead and list them vertically. So here are the 5 numbers, 35, 42, 60, 29, 39. First thing we need to do is find the mean. So if we add those 5 numbers up and divide by 5, we get 41. So I'm going to take all these numbers here, like 35, 42, 60, 29, 39, and I'm going to subtract 41. So 35 minus 41 is minus 6. 42 minus 41 is 1. 60 minus 41 is 19. 29 minus 41 is negative 12. 39 minus 41 is negative 2. If you square them, then that's going to get rid of all the negative signs. So -6 times -6 is positive 36. 1 times 1, or 1 squared, is 1. 19 squared is 361. -12 squared is 144. -2 squared is 4. So here are the squared deviations. I add them up, and I get 546. And then since I had 5 numbers, I'm going to divide by 4. So 546 divided by 4 gives me 136.5. And then finally do the square root. I guess in your calculator, square root would be right here. There you go. 136.5. You see you get the 11.7. So the standard deviation is 11.7. Now, just kind of in graphically, you see the graphs of the 2011 Seattle Marathon and 2008 Olympics Marathon are shown in the next slide. Now the question is, which one has the larger range, interquartile range standard deviation? And why would you expect this? Well, here they are. Should be pretty clear. Range, interquartile range standard deviation. There's much more variation in the Seattle Marathon. And not just because there was more runners. I would say that one of the big reasons for this is that Olympics Marathon is only open to the elite athletes who meet the requirements. Seattle Marathon is open to everyone. So just from the range of runners, Seattle Marathon has a much more variation. And we see that in the times.